All right, so today we will be learning the rule for sine cosine, which is really important because in order to apply all of that, we need to know a certain concept and how we're going to deal with the problem that involving the trigonometry. So for that part of the lecture, we're going to be learning what we call the ASAs. This is what we have for the angle. So that'll be ASA. So meaning that we have two angle and one side length of a triangle. So this is really important to have that. So in order to understand what it is, we're going to look at one triangle and see how we're going to proceed to that. So for that type of questions, that we're going to draw a triangle for that part. And so it doesn't necessarily have to be it doesn't necessarily have to be any angle that we have, as long as that we have a um so it doesn't have to be like it can be any angle generally. So let me just redraw them. Let's say we have this sine and this side and this side. It doesn't look like the good triangle. This side and this side. So we call this one as A and this one as B and this one as C. So yeah. Well, I mean, those are not the right triangles. So let me just rewrite them. So this is A. Let me just let me just make it relatively small to us so that we can really know how to deal with the things. And this part is B. And this part is C. All right, and so again, that the side lane that we're going to use the corresponding side. So this is A, and this is B, and this is C. All right, so remember that the angle with the side lane. So let's say the angle B, the opposite length for that we call the small b. The angle C, the opposite side length of that, so we call C. And the angle A, the opposite for that, so that would be the side length A. It's really important that we utilize that on the questions. So the rule for the cosine will be the following. I'm sorry, for the sine. So the sine rules for an angle, for the angles, okay? And so it's not that bad, but it just depends on whether or not we solve for an angle or we solve for a side plane. Assuming that we want to solve for the side plane, those are the foreign characteristic will be whole. So let's say that would be A over size of 8. So that would be equal to B over size of E and that also equal to the C over size of C. So that basically a thing. Well, I mean, what that means is that the angle and the side plane are proportional for that. So in order to put the angle and the sine, I'm sorry, the side of an angle and the side plane are proportional for that. So now we want to utilize this fact and to solve a following an example. For example, that we have is we have this lane, we have that, and we have this. Okay, so assuming this angle is 78 degree, so this is 78. Okay, and we also have, remember, the question should gives us two angle and one side plane in order to solve from. And this is very important that we're going to use the side rule in order to solve for a certain problem. So assuming that this is 78 degree and oops, let me just rewrite them for that part. And so this is 78. Okay, that looked better. And so this angle will be 46, for example. So it doesn't necessarily have to be like the same thing. You can, came up with any example for that. So that would be 46 degree. And now the side plane that we're going to have will be, it doesn't matter which one. Let's say we have this guy. For example, that we have this guy is a 3.5 meters, okay, for example. So, and so now I want to look for this. I call it this is A, B, C. It doesn't matter what the name. And so this is angle A, and we have with the corresponding side length A. And I have the angle B with the corresponding side length B. And then we have the corresponding angle C with the side length C right there. So the fact is we need to look for an angle C so that we can apply the rule correspondingly. I mean, so the angle C that we know the fact that the total angle would be 180 for the right triangles. So that would be 180 degree. Is pretty much the thing that we should know. And then, so what's going on for that part is we can solve for C by taking the angle C will be 180 minus 78 plus 46. And we can compute that part on the calculator. So we're going to take 180, I subtract, and so the answer for that will be 56 degree. I mean, so this is what we have. Okay, so now we're going to use the side lanes, the right formulas in order to solve a problem. So what we're going to be doing is that we're going to take the 8. So the side length 8 will be the thing that we're looking for. So that would be A over, so over size of A. So size of A would be 78 degree. So what we have to write down, that'll be size of 78 degree. Okay, so and then let me just erase, make it look better. Size of 78 degree. And I want that to be equal to the B will be the side plane that we're looking for. So that would be the B over size of B, right? And so on and so forth. And so we're going to deal with that correspondingly. So that would be the size of B. So that would be 46 degree. And finally, that we have here would be the C. So the C will be the thing that is given. Remember that. So the question gives us the two angle with 78 and 46 degree, and then the length, which is 3.5 degree. So the side length C that we have here will be known. So this part that we can rewrite this as size of 56 degree. So where the 56 coming from? The 56 is something that we just did it. And remember all of that in terms of the degree. So making sure that we not get confused with the radian. So it doesn't matter which one that we're going to use, but since the questions gives us degree, then we have to stick with the degree. So now all we need to do next is that we need to convert them into the side plane for that part. So we know the fact that the C in this case is 3.5 meters, right? So 3.5 meter. So all I have to do, I need to take, so I need to solve A. Those are two lengths I'm looking for. So the 8, I need to multiply both sides by size 78 to the top of it. So I multiply this, I put it there right here, right? So I can have the A will be equal to, so let me just rewrite them so that it look a lot easier. So the A will be equal to C in this case would be 3.5, and I divided by size of 56 degree. So this one will still be unchanged, right? We haven't done anything with that. So we divided by 5.6 degree. I'm sorry, so 56 degree, I apologize. So size of 56 degree, right? And after that, we need to multiply by the size of 78. So this one, you multiply both sides by size of 78 degree. So what we have here would be the size of 78 degree. So, and how are we gonna use the calculator on it? So that would be a big deal for that part. So if we don't know how to use a calculator, it's gonna be really, really sad, because we're gonna fail the exam. So generally that we need to know how to use them. And remember, the calculator, they can download it using the file that we have right here. So let me just check the calculator. So so the calculator that I use is VI83. It's very simple to get it done in this case. And let me just clear everything and start working on it right now. So we're gonna have the question is the 3.5, right? 3.5 times size of 78 degree. So you need to take 3.5, oops, 3.5 times size of, so the size will be here. So that will be 78 degree over size of 56. So size of 78, remember that we need to convert them to the radians by doing times pi. So the pi in this case is, so let me double check if the calculator is in terms of the radians or degree. So let me just convert it to degree and see how it's going to work. So 3.5 times size of 78 divided by size of 56. So, and let's check this out. So we're going to get the answers, which is 4.13. So this is what we have. So the answer for that would be 4.13. And similarly, I can solve for B. So the side length B, again, that we're using, we can use A as well, but it's better to use C. And I can basically figure out B, in this case, the side length. So remember the side length that we're going to use a small letter for that would be 3.5 again. And then we divide it by size of 56 that we unchain because the angle have to go with the side length. So so the C56 have to go with 3.5. And in this case that we can rewrite them as size of 56 degree, and we multiply by size. So in this case, side will be size of 46 degrees, not going to be 78. It's 78, basically the angle that corresponds to the length 8. So I mean, we need to multiply by size of 46. So let me just do that real quick. And again, that we're going to use a calculator for that problem, so that we don't want to waste time. And let's track them out real quick. So we're going to take 3.5 times size of 46 and divide it by size of 56. So we make sure that we're going to open and close parentheses for that, and then we hit equal sign. And so the answer for that will be 3.034. I'm sorry, 3.04. So that would be the final answers. And so we're going to rewrite this as equal to 3.04. So that would be the final answers. So every single questions will be working like that. So unless we want to look for the side root, for the angle, instead of just looking for the side plane, we can also look for the angle as well. But since we're going to skip the inverse function, so we're not going to do with that. Okay, so that's pretty much the thing that we have right here. And so this is the rule for sine. So again, that we need to apply the rule for sine whenever we have two angles and one side plane. Okay, so meaning that the question has two gives. So the questions has two gives, two angles, and one side plane. So whenever we have a certain thing like that, then we apply the side rule. Okay, so the rule will be basically one single rule for that part. Of course, you're not going to prove it unless you really want to do what it is, and this is what we have to do. Okay, so now we're going to go to another rule for that part, is that we call SAS. So the SAS is sort of different. So that would be a one angle and two side lengths. So that would be a little different from what we have so far, and two side planes. So the difference between that and those things is that so the question only gives us one angle, and the thing was we need to figure out the rest of them. So let me draw a triangle real quick. It doesn't necessarily have to be any triangle that we have. So it can be anything that looks nice. And it can be like obtuse angles. It doesn't matter which one, to be completely honest. So I call this guy as A. So this one would be A. I call this guy as B. Actually, it doesn't necessarily have to be like so many angles for that part, but we need to have like two side planes, so the B and C. Okay, so meaning that we're going to utilize this fact to solve for the triangle for that. So the thing that we have to do is that so I want to look for A. Okay, I want to look for A. So the question is going to give us the corresponding angle A, and then we apply the side rule. So and two side lengths. Okay, so so what we have to do is that we're going to take the 8 square will be equal to b square plus c square minus 2bc times cosine of a. And this is what we need to remember that. So a squared would be b squared plus c squared minus 2bc cosine of 8. So it doesn't necessarily have to be the name for that part. So the name that we call it is ABC. Well, it can be any point as long as that we have the opposite angle and the two side plane, so that we can figure out the side plane correspondingly using that formula. So this is a very powerful formula that we're going to use. So, and let's take a look at one example for that. So let's do one example. So let me just figure it out. Let's do one example for that part and see how we. So instead of we have this, so let's take that. It doesn't matter which one. So assuming that this angle is 160 degree, 150, that should be good. Okay, so that should be 150 degree. And I need to solve for an angle, I need to solve for this side length, given by this one equal to 4.6. And this one is given by let's say 5.7, and they want to solve for 8. And generally, what we have to do is applying the formula. So we have a squared will be equal to 4.6 squared. So I'm going to put the square later on, plus 5.7 squared minus 2 times 4.6 times 5.7 times the cosine of 150 degree. And that's pretty much the thing that we have to do. So so we're going to use that to connect them. So that'll be a squared equal to b squared plus c squared minus 2ab times cosine of 150 degree. And so we're going to use a calculator for that. And in this case, so we're going to take 4.6 squared plus 5.7 squared minus, so this one is subtract. And let me just delete that. Subtract 2 times 4.6 times 5.7 times cosine of 150 degrees. So everything already in terms of the angle. So we have the answers will be 99.06. And so that will be our things that we're going to put them down. So so we have a squared equal to 99.06. Okay, and finally that we need to solve for a. We're going to take the square root for that. So the a would be the square root of 99.06. And of course, we're going to use the form calculator again. So it should be around 10, so that should be 9 point something, 9.9, 9.8 in this case. So we're going to take the square root of that. We're going to hit second and x square. And we're going to get 0.06. So the answer is just 9.95. So that'll be the final answers for this question. Okay, so so this one will be 9.95, and that's pretty much a thing that we can do with any angles. So I just want to make sure that all the work is correct. So I'm going to use another functions for this part. Instead of using degree, I want to check for the radian and see how it's going to work. So that'll be 4.6 and square plus 5.7 square minus 2 times 4.6 times 5.7 times cosine of 150. So times pi, because we basically convert them to the radian. So I need to multiply by second and pi, and hit the second and that one. You can see a little pi on the top of it, and divide it by 180, and so we should be able to get the same thing. And I mean, there's no trick behind them. It's just the way that we saw a problem like that. So we can continue on one more example. Remember that we just need one angle for that part. And if you ask me, can we use the rule of sine to solve for that? So the answer is yes, but it's gonna be a little more complicated because we need to look for an angle for that part using the rule, an angle for that part using another rule for this, and then we solve for the for this sine length, which is pretty much the thing that we have to do so far. So this is what we call the rule of cosine. So let me just rewrite them through the cosine rule. Okay, and pretty much the thing that we have to deal with so far. And let me just do one more example and see. That's pretty much the same thing again, that the question must gives us, let's say, an angle. So let's say if this angle is 60 degree. Let me just do that again. So this angle will be 60 degree. And this side length is 2.4. And this one is 5.3. So this one is 60 degree. So just want to be like working on it. And so we basically going to apply the thing that we have will be a square equal to 2.4 square plus 5.3 square minus 2 times 2.4 times 5.3 times cosine of 60. And we're going to finish that right here for that question. So you put the square and square and square, and this is degree. Okay, so then I'm going to do the calculator one more time. So we need to convert to the angle. So go to the third ones and click on degree and see how it's going to work. So we're going to take 2.4, and so the answer will be 2.4 square plus 5.3 square. Oops. And minus 2 times 2.4 times 5.3 times cosine of 60. Okay, so the answer for that was 21.13, but this is not a final answer. This is the answers for a square. So we're going to rewrite that. So this guy will be equal to 21.13. And now we're gonna solve for that. So the a will be the square root for that. So that will be the square root of 21.13. So we're gonna get the final answers correctly. So we're gonna take the square root of 21.13. We close it. We get the answer, which is 4.59, which is 4.6, around that. All right, and that's pretty much the thing that we do today. And hopefully that you guys are going to have a very effective day of learning before we have the exam on Thursday. All right. So if you have any questions, make sure that we're gonna see me in the office hours. and the same time for that part, and ask me any question you can, especially when you look at the exam 4 review questions, and just try to practice for that. All right.